Every AI assistant you've ever used has the same dirty secret. The moment the conversation ends, it forgets you completely. Not partially, completely. Start a new session and you're a stranger again. You've explained your project 3 times this week. You'll explain it again tomorrow. That's not intelligence. That's a very expensive notepad. Rekal is a Python library that gives LLMs persistent memory, and it ships as a single SQLite file. No vector database subscription, no Pinecone account, no cloud infrastructure to manage. One file on your disk, and your AI finally remembers. Let's talk about what this actually does in practice. When your application uses Rekal, every message in a conversation gets stored with its semantic embedding, a numerical fingerprint of what that message means. When the LLM needs context, Rekal runs a similarity search against that SQLite file and pulls back the most relevant memories, not just the most recent ones, the most relevant ones. That distinction matters enormously. Say you're building a coding assistant. A user mentions on day 1 that they prefer TypeScript and hate class-based components. 3 weeks later, they ask for help with a new feature. Without memory, your assistant starts from 0. With Rekal, it retrieves that preference automatically, and the response it generates already fits the user's style. The user never had to repeat themselves. The setup is minimal. You install the package, point it at a file path, and Rekal handles the rest. There's no Docker container to spin up, no API key for a third-party memory service, no monthly bill for storing embeddings in the cloud. The entire memory store is a portable weak.db file you can copy, backup, or ship with your application. But here's the things, and this is where honest evaluation matters. Rekal is not a drop-in replacement for production-scale vector databases. SQLite is fast for single-user workloads. It is not designed for concurrent writes from multiple processes. If you're building a multi-tenant SaaS where thousands of users are generating memories simultaneously, you will hit locking issues. SQLite serializes writes, and at scale, that becomes a bottleneck. Rekal's author is transparent about this. It's not hidden in the fine print. Also, the semantic search quality depends entirely on the embedding model you pair it with. Rekal stores and retrieves embeddings. It doesn't generate them. You bring your own embedder. Use a weak model, and your memory retrieval will be weak. Use something like a sentence transformer or OpenAI's embedding endpoint, and results get genuinely good. The library is model agnostic, which is a feature, but it also means quality is your responsibility. There's no built-in memory decay either. Every stored memory has equal weight unless you implement your own scoring logic. A message from 2 years ago gets the same consideration as one from yesterday. For some applications, that's fine. For others, especially anything conversational, you want recent context to dominate, and right now, you'd need to build that yourself. What surprised me was how realistic the near-term potential here actually is. The single-file constraint isn't a limitation. It's the whole point for a specific category of deployment. Think about local AI tools, desktop applications built on Ollama or LM Studio, privacy-first assistants that cannot send data to a cloud service, Raspberry Pi projects, embedded environments. Every one of these has the same problem. They need memory, and they need it to stay local. Rekal is genuinely the right architecture for that entire class of application. If DigitalOcean droplets or small VPS instances are part of your stack, single-user tools, personal productivity apps, developer utilities, you can deploy Rekal alongside your application without any additional services. The memory file lives right next to your code. There's also a legitimate path towards smarter memory management. Implementing a recency-weighted scoring layer on top of the existing retrieval logic is straightforward. Capping memory store size with a rolling window is equally achievable. A future version of Rekal with optional built-in decay could cover a much larger percentage of production use cases without ever touching the core SQLite architecture. So why does this exist? Because the mainstream solutions to LLM memory have a hidden cost that most tutorials don't mention. Vector database subscriptions run $40, $80, $200 a month depending on scale. For indie developers, for local tools, for projects that don't need enterprise infrastructure, that cost is a barrier. Sometimes it's the reason a project doesn't get built at all. Rekal's author looked at that gap and built the simplest possible thing that works. Not the most scalable, not the most feature-rich, the most deployable. A library you can install in 30 seconds that gives your AI a memory it will actually keep. Is it perfect? No. Single-user workloads only at any serious volume. No built-in decay, quality tied to your embedder. But for local AI applications, privacy-first tools, and solo developers who just want their assistant to remember who they are, this is one of the more quietly useful things I've seen shipped this year. Next episode, we're looking at a tool that runs the entire RAG pipeline: retrieval, chunking, re-ranking, inside a single Python function with no external dependencies. If today's episode clicked for you, that one will hit even harder. Subscribe so you don't miss it.